Hello everyone, and if you can hear us and see us, please set your thumbs up to the YouTube chat, because that's David Gilardi and Alex Volishnev together with you for the Data Stacks Monday learning. Welcome!
Hello!
Okay, so how it looks? Can you see us? Everything is fine?
Yeah, definitely let us know in the chat if you can hear us and everything looks good.
Yeah, but at least...
Oh, hi, Pranav.
At my side, it looks good, so we should be fine.
Yeah, same here. I see a good stream myself in YouTube. Good. I see all fine from Matt 10243X.
Perfect.
Hi, Pranali. Yeah, I see some familiar faces, so that's cool.
Yeah, that's always amazing to see familiar faces, but new faces are very well welcomed as well. And that's Data Stacks Monday Learning, the great day to start the week, to upgrade yourself and learn something new. And that's Alex Volishnev, directly from Kaiserslautern, Germany, and with me, David Gilardi from, sorry, David, where?
Orlando, Florida, in the United States of America.
I'm very curious about how many kilometers, or maybe miles, if it's more comfortable for you, between two of us. It should be a lot.
Jeez. It's many thousands, yes. It's a good amount.
Yeah.
It's, I need to take a plane or a big, a boat for a while to get there, one of the two.
Yeah, definitely. And we have people at this course joining us from all over the earth. So I've seen over 25 or maybe 30 different countries in the registration form. I see people from, I don't know, Italy, Brazil, United States, of course, a lot of people from Europe. And India, and so on and so forth. That's amazing. Okay, so we don't want to wait for too long, and let us start, because today we are going to cover very important thing. And if you just joined us and don't know what's going on in general here, that's a Docker Containers from Basics and to Best Practices course which should have been just 4 weeks, but due to high demand and as you push it so hard on my boss and to our team, we decided to extend that to the 5th week, and it's going to be Introduction to Kubernetes. So that's a great news. We extended that to just 1 more week, and we will cover Kubernetes as well due to high demand. Important thing, please share the news. Like all the workshops before, we built one over the first one, over the previous, and Kubernetes things and best practices in general workshop, more or less standalone. So you can completely invite your friends who are already into Docker but want to improve the knowledge, and who is not so much into the Kubernetes, for example. We are going to do Kubernetes workshop, a really hands-on, so you will work a lot with Kubernetes. It's the best way to learn any new technology. Good. So, what comes next? Just before we start, that's exciting how many people we have this course. So even registration keeps growing, although we are in the middle, but still people are joining us, and that's great. You are never too late. We are always ready to answer your questions. And that's like the number which even scares me a bit, David. We have overall more than 2,000 hours overall watch time.
I gotta say, Alex, like when we do these, and depending on the amount of folks, those numbers after every one of these sessions are always just kind of a little bit amazing to me, because to think that cumulatively you have all these folks that spend time with us, and it'll tell you like how many days. Like there was one session we did that literally with the number of people on and everything, it accounted to like half a year of watch time, and it was just like, oh wow. So I hope that the material is, well worth it, that's for sure, because we're spending lots of time with everybody here on YouTube.
We are really happy what you trust us, the most essential resource you have, because, well, time, that's what matters even more than money. And we want to say thank you. If I just calculated out of curiosity, if one person would watch those workshops alone, it would take 83 days to watch it 2,000 hours. So that's incredible. Okay, let's raise those numbers a little bit. But first of all, Thank you so much. And we are starting, and that's going to be week 2, week 3, sorry, already week 3, application development with Docker. So we discussed a lot of things before, how Docker works, why you may need that. But now the thing we have to cover is how exactly do you develop applications with Docker. As soon as you start to use Docker, you may find out what some things just changed in comparison with how you were developing things before. And that's for a real reason, because, well, there are some changes. And I can tell you, out of all the Docker popularity in the world, a lot of companies, teams, projects still using it very, I wouldn't say wrong, but, well, it could be used in a better way. So Docker needs some new tools, and Docker needs some new knowledge. And it all starts from the very beginning. Imagine a new developer coming into the new project and getting ready to work. And first thing he or she would like to do is obviously just start the application. Not even developing that. It may take some time to prepare, read some documentation and so on, but just make it running and check if it works, if I can log in, if I can, I don't know, use this application in general. And in the company I was working before, so no names, but it's an absolutely real story. I told it to you last week. Preparation and running first launch of a complex system at the developer's laptop took around 2 work days. So
Wow.
around 16 work hours, and that's just incredible. So first thing I want to tell you, and first goal you want to reach, doing things with Docker. Don't forget, the deployment should be a question of minutes maximum to run your new application. As we finished it with a containerization, starting application on a completely new machine was usually around 10, 12, 15 minutes, depending on network conditions, because there were some really heavy Docker images involved. But it at least wasn't 16 hours. So, that should be a question of minutes to run an app on any new Docker-ready machine. And simple, reproducible environment is the key to successful development. There should be 2 commands to run your application on a new machine: git clone, docker compose app. There are some cases you may need to have a little bit more, but at least it should be 2, 3, 4, 5 maximum simple operations. If it takes longer, then something is wrong in the setup, and you want to avoid that. And that's what always matters, like it should be ready to scale horizontally very quickly. One thing to consider, speaking of application development, is it Monorepo or Polyrepo? This concept came when microservices start to take over the world. And what's the Polyrepo, what's the Monorepo, and why it matters for us speaking about Docker? Very easy to explain. Like we use it to work with monorepository, it was the times we were using monolithic applications. So you have everything, I don't know, web part, mobile part, so all the services and libraries together within the single Git repository. And Polyrepo is when you're working with application, speaking of microservices, which consists of multiple moving parts, and you have one repository per one service and per one library. And now your team works not with a single Git repo, but with many of them. What's the difference and why should we care? Then we have Monorepo. It's very easy to decide. Okay, that's our Monorepo. I'm writing Docker compose YAML file right here because it's the one and only place, and I'm launching it here, and everything is fine. If you are switching to Polyrepo, first of all, Monorepo is not so bad, even for microservices, but we aren't talking about them today. We will speak about them later at the Data Stacks Monday Learning, but not today. Then it may be a question like where exactly I should put my Docker compose. How I start running project using my Docker compose YAML files, or maybe I need multiple of them. Should I have one Docker compose per every of my repositories or something like that? There are different approaches. And technically, we utilize both. So that's the thing to show, for example. Have you heard of killer video, David?
I sure hope so.
Yeah, I know.
Because if I haven't at this point, then it might be problematic for writing part of it. But
yeah.
Yes, I'm familiar with killer video.
So, for those of you who don't know, that's our reference application we use to show how we work with Apache Cassandra and DataStax Enterprise. It's pretty distributed, big application with different services working together and different backends. We have backends on Java, C#, Node.js, Python, whatever. And that's Polyrepo, as you could see. So we have separate killer video Java, killer video C#, Node.js, and so on and so forth. And there are more repositories here downstairs. So how do we unite that all together? We just, as we are having already a lot of repos, +1, -1 doesn't really matter. And here we go with first method for Polyrepo projects. Call it, there are different options. I stick to all-in-one. Some companies call it main and so on and so forth. But that's not a question of the name, because it consists basically of one main file, Docker Compose YAML, which describes how all this application works together. And some more additions we will discuss later during the day. And there are some sweet Kubernetes definitions we again will cover in 2 weeks later, I promise. So, and here in those Docker Compose, we describe all the application and how it's supposed to work by default. So how do you run killer video? You do git clone, killer video all in one, Docker Compose up, and it's set. And that's basically a very simple thing, and that's how your application should be running.
So I'm kind of curious, actually, for those in the chat, how many of you are using monorepos and how many of you are using polyrepos? I'm really curious.
Very good question. So you know what? After I was originally using monorepos, of course. I mean, as all of us. When we start to use service-oriented architecture and we switch to Polyrepo, and I can say what if I would do it again now, I would do it in Monorepo, even distributed.
Really?
Yes. You see, what's the biggest problem of a Monorepo and Polyrepo in comparison with Monorepo? What's Git all about? Git is all about changes and changes management. So if you are doing your Git commit and you have a ticket in Jira, you write in your Git commit message ticket number 1552. And then following the Git history, we can see who did that, when it was done, which ticket it was related, and so on. Git is about managing changes, change sets. And very often, you don't do just a single change. So very often, one of your change relates to another. And you are changing the way how service A communicates with service B. And if it's a monorepo and your services will store it together, even if they run isolated one from another, from completely different machines with Kubernetes all over the world, that doesn't matter. So with monorepo, you can set a single change set which relates to each other, and you see how this change is managed. And with Polyrepo, there is no way to make a cross-link on these change sets. So you basically have no direct relation between them, and it may happen, for example, and it happened for many companies, what they release Service A version 2, which requires Service B version 2, but as there is no way to link directly their versions, for example, and change sets using Git, okay, there are some dependencies management, but still there is a fat chance what they will not relate directly to each other, and you will have where Service A version 2 requires Service B version 2, which is not deployed. An application is not operational. By itself, both parts are operational, but they are not operational after that. So now I think what Monorepo is, for many cases, will be a very good decision. But we aren't speaking about Git flows. We are speaking about Docker, so let us move on. And I see people Monorepo, Polyrepo, Monorepo. So Monorepo is not bad by per se. Just consider some limitations of both Monorepo and Polyrepo. We will discuss it later if you would like to, but not today. So, okay, that's our intermediate repository, Killer Video All-in-One, and we have those Docker composers here, and we have also a bunch of applications which make this application working together. So I explained what's the difference between Monorepo and Polyrepo, and why, speaking of Polyrepo, you may have a special repo for your Docker Compose and to manage. But there is a second way which you may like more. And again, there is no correct and wrong, but something what fits better to your case. If we go to Killer Video Java, which is one of the backend parts of a Killer Video, we may find Docker Compose here as well. And moreover, we can find two of them. We have Docker Compose CI and Docker Compose YAML. Why and what's the difference? So, the main Docker Compose is initially, the main one is all-in-one, is designed to just have your application running within 2 clicks. And this Docker Compose YAML is already for those who are going to work with the backend. And if we open it here, we see immediately, so what, for example, instead, okay, wait a second. I changed it locally already. So we can easily switch from image version to build version, and next version of the file we are speaking here is Docker Compose CI. As you could guess, relates to continuous integration we cover later today, and it's simplified version because for continuous integration tests, I don't need to have web frontend, for example, and I don't need to have many other services. So when I run continuous integration tests, all I need is this local image of Killer Video Java local. I will show how it works soon. I will need database because those are integration tests. Those require really database. And configuration image, which which is not interesting for us right now.
Hey Alex, before you get too far on this, there's a question in YouTube from Afonso when we were talking about the Mono and Poly piece. What happens with the storage in these cases? Is it added according to the work environment?
Yes, so very clear. When I just want to run application, there are no volumes and there is nothing special like this because I first want to run it. And if then I go to change something, I'm a bit surprised that it's not committed to this file. So let me show you. Oops, that's something that's wrong at all. Sorry, I launched it wrong up. And actually this question is answered exactly on the next slide.
Well, thank you, Alfonso, for playing straight person there and walking us
being a little bit ahead of time. That's very fine. I love questions like that. Thinking. Yes. So, and if I switch to my Java thing, so we will work with the same application. Hey, code, could you please start? Okay. So we have Docker Compose here, and then I'm going to work with the application. I'm doing very simple thing. I have first to comment out image because I'm not going to, well, in some cases it may not require it. Like if you never change, what's going on? Not now. And in some cases that's not required and I can keep using image, but I prefer to switch to build. And then I specify where to build, and I'm going to build local folder because I'm currently located in the Killer Video Java part. If you use all-in-one approach, path will be different. And then I have to set up a volumes.
So just to be clear, so you're essentially using the build within your Docker Compose in lieu of having a pre-built image. So this way, as you're making changes locally or whatever you're working on your code, every time you run this, you're going to rebuild and then use that image?
Nope,
For the
no way.
debug
So you are running
Or not
ahead
use
of
the image,
time as
sorry.
well.
I said that wrong.
Of course, I don't want to restart it every time. Ah, stop. Yes.
Right.
Okay, I did it in the wrong part. I started to fix front end. I may need working with backend. Sorry. So I'm going to wipe out this one. Da, come on. And we will need volumes, and I'm mounting local folder to, it's going to be, what was it, opt killer video Java. And speaking about slides, that's exactly the next slide. Source code. I will not even open it. And the way how we do it. So the easiest way for us to pass through the local changes and the files we are changing locally to a container is a bind mount. If you remember week 2, that's exactly the point we discussed. You bind mount that and you have all your changes. And that's the very simple change set we have to do. We need to switch to build, which is, let's say, in general recommended. So you will see how it works and you can rebuild it if required. You don't have to rebuild image in general, so that's to be shown soon. And oh my god.
And hopefully Pranali, matter of fact, Pranali asked the very question, what's the difference between appending, build, and image? It looks like you're addressing it right now, so hopefully Pranali, you're going to get the answer.
Yeah. So you remember Docker Compose is just a configuration file which tells to Docker what to do, like what do we want to have in the end. So build means what I will, instead of using permanent image with Docker run pull an image, I will build image right here before using that. So that's for Docker build. And with volumes, I'm mounting that to use local folder in the opt killer video Java folder of a container. And then finally, we can go on to the next part and add some environment specific data. So, did I answer the question, I hope? Difference between appending build image. Yeah, so I hope I've answered.
Yeah, Pranali, let us know if you have any follow-up questions to that or if that answered what you were curious about.
Good. Good. Then switch me back to my browser, please.
Okay. Yeah, Pranali says yes.
Good. So we have now our Docker Compose file, which describes all our system we are going to run. It may be something simple like WordPress plus MySQL we did last week. It also can be very, very complex, like something with huge... Oh my god, I just stopped you. Stop bugging me. Sorry. Hey, there is my browser.
Oh, we get to see Alex's desktop. What's on there?
It's a very rare case. Usually no one sees my desktop. Okay, so we have a Docker Compose describing our system. We add build and volumes instructions to the Docker Compose to specify we are going not use existing image, but we are going to use to build that when required. Again, you do not have to rebuild image every time you do any changes. It's easier than that. Docker is to simplify development, not to make it harder. If it would be harder, I would not talk to you right now. And we bind mount volumes to have our code inside the container. Then some more things to discuss. Environment specific data. What's the environment specific data by itself? Very easy to say. It's something what changes from environment to environment. And what do I mean by environment? That's your laptop, my laptop, that's our production server, and that's our testing server. And you don't want your production server database password to be available on any laptop of any developer of your team, except if it's a team of one. but usually it's a little bit bigger, so you have to treat environment-specific data specially. So there are some things changed, and we have to take care of them very properly. And first thing, do not keep sensitive data in source code. I really seen some people keeping these production database passwords in Git in source code, and that's a very bad idea. As long as you put something under Git, very probably very soon a lot of people who shouldn't have access to this data will have access to this data. Do not keep sensitive data in source code. Never. Now, on the example of the right, we see this part of a killer video, one of a killer video services, killer video generator. If you would watch to our code, we use environment variable, killer video API key, set your YouTube key here. Is it good or is it not so good? Let's think. Well, so YouTube key is not stored publicly here. That's already something. Very well. But there is a problem. For example, someone working with this application will really put the YouTube key there, of course, because, well, that's how generator works. It needs connection with YouTube. And then doing a huge change set, a developer may forget to remove the essential sensitive data before pushing it to Git. And boom, we again have YouTube key pushed to a Git. And that's again wrong. So is there a way to improve that? Yes, there is, and that's why we are here for now. That's a much better way using environment files. In this case, code on the right is exactly the same like it was before, except of the environment directive in Docker compose YAML file. We have this env file. The only what changed is we moved our environment variables to file called dev.env. And that's the file, I need a pointer, and that's the file dev.env we are having right now. And all my variables are here, and this file is under git ignore. That means what? It doesn't belong to Git and will be never delivered there. Please notice.
So you're protecting yourself, right? As an application developer, you're protecting yourself to ensure that these environment variables are the values are never going to end up in the other systems.
Exactly. Yeah, that's a good notice. And you know what? I consider myself as a very disciplined developer. I'm always reviewing my own change set before at least pushing them, and usually before committing them. But you know what, in once more than 15 years, it happened once or twice. I was pushing things I would not push, and I checking things very strongly. So I do think it may happen with everyone, even you control yourself all the time. In this approach,
totally. How many of you watching us right now have totally either wiped out data or taken down a system? Give us a thumbs up. And if you did it because of environment variables, it's okay. We're not recording these. We're not going to, let the world know.
Yeah.
I've definitely had a couple.
Yeah, definitely. So this way we protect ourselves. Local setup is in dev.env. Everything super protected key is in dev.env. And dev.env is in git ignore. Therefore, it's not seen. It will not be committed and push it to a repo by mistake, and you are protected. And the only missing thing here is what dev.env. Well, therefore you have to fill somehow, because it will, when you do a git clone, file will be not delivered. In this case, what we do, we have file dev.env.default with some default settings, which may be enough, maybe not enough. And we have in the instructions in README for the project, and you have README, do you? At least you should. And then where it's how to run the project, git clone, copy paste dev.env default to dev.env, change the value, and boom, you are done. You can run a Docker Compose app. Notice one thing, which is a very common mistake. People use it copying values from YAML file. People use it to have it like dash space key name double point space value. And with env files, it works differently. just name and equal sign with no spaces and immediately value. And that's a very common mistake. People forgot to rework it like that. It looks more like Linux environment variables file because
It's a little cleaner too.
Technically it is. And finally, is the array even easier? Yes and no. So watch the last example of this part. We have this file with no things defined at all, and we have -env environment files which will be passed and which may be used directly in the environment things, and you don't have to define them in the Docker Compose. That's an obvious way how it works. So the case when convention is over is more than configuration. Personally, I don't use that because although it works, and in some use cases it may be convenient with this default.env file, which is magically populated to a Docker Compose file with environment variables, it's special case which personally I don't like. There is a question in chat. Is it possible to use public or private keys encryption with Docker Compose files? I'm not sure what, Artur, I'm not sure exactly what do you mean. Encryption and signing of the images exists, but definitely out of scope for today. Maybe I misunderstood the question. But anyway, let us move on if we want to be on time. Now, there is one thing. That's not enough to define environment variables. We also have to use them, and as now we are not just using applications like we were using during those two classes, but also developing them, we have to work with environment variables in our application. Do you remember before at the workshop 2, I launched MySQL specifying MySQL root password, and here it was. So there is no magic. It was processed by a script, start script and the MySQL container, and use it properly. And as we are configuring our applications via environment variables, we also have to support them. So there are a lot of different applications, languages and frameworks suggesting it to do it in the different way. And if we would try to cover all main of them, we are going to be done by tomorrow. And I will cover only only two languages. Those I mentioned the most during the last workshops, Python and Java. But any modern language provides the tools to work with environment variables. So I hope you will be able to find required tools. In our case here, in the first example, we are using Python, and we are defining function that's a copy-paste of a killer video Python backend, which is taking the environment variables, giving by their name with os.getEnv and the name, and downward and here a little bit down the same, but using some default settings, which we will cover in a moment. For Java, it's mostly the same, but we are using system.getEnv and specifying values what we need. If the keys what we need to grab. If we don't specify the keys, we will grab all the list of environment variables available for this application. Now, that's at least for me very important thing is developer experience. What is developer experience? We don't speak about the years of development experience in this case, but more like, UX, user experience. In general, how convenient for a customer, for a client to use your application. So we should remember the DX. DX, developer experience, is how convenient for a developer to develop your application. And that's really important because people always forget about us developers. So we should at least take care of each other. And what we want to see here, I'm always trying to add default variables, most commonly used variables. So when you don't want to specify something and just want to run, default mostly used variables will be defined already with those default values like here. And I don't need to do too much environment variable definitions in order to launch the application. I just want to launch that. It makes my work easier.
You know, Alex,
Yep.
by the way, a follow-up to the question from Arthur with regard to, is it possible to use public and private keys encryption with Docker Compose? Then he followed up with, like in PuTTY, for example. And Abhinav had said maybe he's asking to encrypt the Docker Compose file. I'm wondering, yeah, I'm also wondering where that applies, because I'm thinking where I'd use them for PuTTY, right? If I was using public-private keys for the actual connection to the other system that I'm trying to say SSH into or something, I'm also kind of missing what we're encrypting in that question.
Yes, I'm sorry, I still don't understand. If we are trying to connect one container to another, then there is no point for encryption because they're in the same network, and this network is considered protected. And if you are using it in production with hundreds of servers, and you want to set some trust between services, then you will not going to use Docker Compose anyway, because there are some better approaches to handle multi-host Docker systems, like Kubernetes we will cover 2 weeks later. So I will be very happy to proceed with this discussion about encryption, but in Discord better after the workshop. Yes, so we have to move on. Now, getting to build and run, and that's very important to understand what build and run are two different processes, and that's very important to remember. So, first of all, like a typical situation I've seen by people developing who start to develop with Docker. Hey David, are you with me? It looks like we have an issue with connection to David, but stream goes well. Hey David. Okay. Okay, I will try to proceed alone. Can you hear me? Everything is fine? Hello, everyone. Hello? Oh, great. Great to have you back, or great to have me back. I'm not sure.
Yeah, I'm not sure which one of us went back or whatever.
Yeah, but well, doesn't matter. We can proceed anyway. So, thing I wanted to say, I've seen really people rebuilding Docker container every time they do have to change something, and that's of course completely wrong. So build and run processes will be very different for different applications. That's like we have compilable applications with Java, and we have interpreted language like Python or many other languages, and approach is different. But in general, in most cases, in all cases or almost all cases maybe, you don't have to rebuild or even restart containers actually, because very often just restart process will be completely enough. And if we work with interpretable, oh my god, that's like really 8 p.m. already, sorry. So, if you work with languages like Python, with interpreter, then the only first point is to deliver code to the container. But it's delivered already because we did this bind mount earlier today, you remember? And then after that, we simply can restart that. So the easiest way to restart the whole container will be Docker restart. Another option will be just to restart the process within the container, which is also works very well. Second point, which is a little bit harder for compilable languages. So you have to compile, obviously, a new jar file. It may be a question, for example. But that's all. That's, again, doesn't require rebuild of the image per se. It depends on how exactly it's done. And important point again here, if we take a look at some images I will show you right now, you will see how many people are doing mistake by putting their putting their build dependencies into runtime. And there is a very huge difference. Build dependencies you need only on build and don't need that after that. And runtime dependencies you need during the runtime. And for example, take a look at these shiny, where is my browser? Hey, yeah, perfect. We have his killer video Java. Take a look at this Docker file here. Look how tiny it is. Isn't that great? That's just like 7 lines counting comments, which is really like comment. It's very short and easy to understand. We use official Java Java image. We specify maintainers of this image, which is technically deprecated technique right now, and we should do it differently. So maintainer directive is deprecated. We specify entry point, so which particular command container is going to run on startup. We expose the port. For us, it's port 5101. It's the default port for backend service in Killer Video. And finally, we copy file, which is going to be executed. And that's interesting something about this Docker image, if you think. It's very small, it's easy to read, easy to build. Build it up considering this part changes nearly never. It all comes from cache, and copy file is also a question of half second, let's say. So it's good or maybe not so good, or at least maybe special. I can tell you, it's not self-sufficient Docker file. So for it to work, someone needs to have this file to be built. And only then this file exists, this Docker file will work. And if it doesn't exist, this Docker file will fail because there are no source target killer video Java jar. And therefore, this thing is not sufficient. And it's fine in this case because of the team conventions. Like people who developed this thing all have Java installed locally. I do it differently. I prefer not to pull my dependencies on my laptop because I'm working with dozens of different projects. If I would pull all the languages and all the dependencies, all the frameworks on my laptop, it would be exploded in a couple of months. So I keep everything in Java. But I still can do the same when I use the approach of the do 2 Docker images per project. 1 Docker image to build, having all the build dependencies, and I run the build in this image, and I receive this Java jar file in the end. And then finally, I just add it to the production image, which I have right here. And this keeps this image pretty small because there are no build time dependencies. Great. And if you want your image to be more self-sufficient and you just say Docker build and everything is done, then maybe you will not like this file which I will show you now, especially in comparison with the Java's one, smallest one. If we take, for example, this guy.
Alex, while you're doing that, sorry, Eddie's got a question.
Shoot.
On YouTube, how would you combine it with CI?
I will show you. I will show you. I
love how all the questions that are coming in are ones that are like, it's in the next slide.
Yeah, it's in the next slide. Well, you see, I'm developing with Docker since, let's say, very early adoption of the Docker in the world. And basically, I know what people are asking about. So it's in the slides later. So if we see Docker file for this killer video generator, which is another backend service for the killer video, it will look a little bit differently. And let's walk a little bit through it and understand why it's this way. So in comparison with the Docker image you've seen before, this image installs all the dependencies of a runtime and then gets rid of them in the very proper way. So this one is a pretty old file. So now it uses Node.js version 6. Oh my God, it was outdated like ages ago, but it's still operational. So let's take a look how it works and why it works exactly this way. In general, let's cover it in the next workshop about best practices. But there are some things to notice for us right now as well. First of all, in the Node version 6, everything was launched with a root user, Linux administrative user with no limits and no concept of permissions. It just has full access over everything, and we want to fix that. So we are creating group and user for our killer video user, which will be running this process. We set default node-env production environment. So we define default environment variable node-env production. What does that mean? If you want to run this image on development environment to have some better output and traceability of errors, then you always can run it with the environment variable node-env development, and it will work well. But if you forget to do that at all, application will not fail because node-env is set. It will simply running in production. We are preparing some place to run this application. So we will make directory opt killer video generator and chown it to our newly created killer video user. And we also set this directory as a working directory. When we copy two files, package.json and npm shrink wrap.json, if you are into the JavaScript and Node.js programming, you know what is it. If you don't, not really important. That's just dependency management. So package.json defines which dependencies we are going to use, and npm shrink wrap specifies the particular versions of these dependencies. And finally, this huge, tremendous, awful, or maybe not so awful command, which I really have to explain why it's done this way and why it's a best practice. Seriously. I know how it looks like. So first of all, our killer video generator has some really heavy dependencies with complex dependencies. We cannot simply make npm install because, well, it's going to be harder than that, and we have to install some very special things. And why don't we just say run apt-get update, run apt-get install, run npm install, and so on. So there is a little secret. Then Docker executes your Docker file directive. Every step is executed in a special container. We run containers with the containers to run containers while running containers. Simple as that. And as all your commands are executed in this temporary container, it will be committed with Docker commit command. We never discussed it before. And boom, we have a next image. And the trick is those commits and those Docker layers, they are about changes as well. And if I do docker run apt-get update, docker run apt-get install Python, docker apt-get auto remove, and remove the folders where those temporary dependencies are stored, in the end I will not have image as small as before, but I will have twice increased images, because on the first change set I'm adding all the apt-get update things, and on the second change set I'm removing them. So it will be not as easy as it was before, but twice heavier. So if you do some temporary operations, I just want to do npm install, but to do that I need all those things, Python, make, and G++. Therefore I want to install them, make npm install, and remove them and clean up all during the single run directive. Only this way my image will be still thin with all the redundant dependencies not installed. And that's pretty interesting. Then I copy my local code to this killer video generator thing with all the dependencies installed as well. And finally, I'm using interesting thing. So you already know env. Env allows us to define environment variable like we did in the beginning with node-env production. But there is another thing which is called arg. Arg relates to build argument, and I can inject environment variable if I would like to on the build runtime. So like we run docker run -e or docker compose environment, we can include some environment variables on build time, not on runtime. Why it's important? In this case, I want to have this defined and built into the image to simplify usage of that. Yeah. And the rest of the thing should be familiar to you. I define user, so by which user I'm going to do the rest of the commands. And the last command will be cmd and run this my killer video generator. Getting back to the point, that's pretty a lot of things said. Two things you have to remember. Build time and runtime, those are different. First. Second, in some cases you want your Docker file to be self-sustained. But in some cases it may be pretty hard and big in the end. And at least if you are using this not obvious way, so this Docker file will not simply work, add it to the documentation. In order to execute and build this thing, you need to have first compile the file, and then it will be copied to a production image. And you can do it using your own local installation, or you can use dedicated build image, which will be used only to build thing. It would be based on Maven, as I say in this case. But that's not our point, because our great guys are doing that locally with locally installed Maven. And then, how do we run them? As said, as we bring any changes, we didn't change the main image thing, like we didn't touch Docker compose file, we didn't file Docker, we didn't touch Docker file. The only thing we have to do usually is just to restart the container if we speak about interpretable language. If we speak about compilable languages, you will still need to have to compile the deliverable.
Alex, we have a question from Vikrant in YouTube. I think this is relevant to what we were just talking about, where you were just talking about. When we are running the command, the way apt-get install, part of shown node Docker file, does this mean all the commands run on different contains, and then a combined container will be our resultant container where we'll run the app and create the image?
First of all, thank you. Second of all, almost. So take a look. We speak on a build time. Notice that's important. We don't speak on runtime, but we speak on build time. Every time in the beginning and in the end of every directive, there will be an image, and every command, like run at least copy, will be executed in a container, temporary container, which is used only to build the next image. For example, here we're downloading Node 6.11 Slim, and that's an image. When we have to run this command, how do we run this command? We run a container out of this image and do those commands. And now we do docker commit command, which will create a new image based on container. So now we have image which has base node 6.11, but we've group added and user added. When we set this environment variable, the same. When we create a folder, the same. So every time new container is launched, command is executed, and finally container terminated, and we have temporary image. And in the very end, we have final image you are working with. And all the intermediate steps, maybe clean it up if you don't need them anymore, or use it for caching purposes. Cool. So, we discussed some things about building and running. And now, I've seen it already a few times. When people have everything of their projects in Docker Compose, except of the application they're developing. So we have databases in the Docker Compose, we have some caching services in the Docker Compose, and everything except of the application by itself they're doing still locally. And then there is a huge complex workaround to make application running locally be able to contact containers and vice versa, because while they're using different networks, your application running locally runs as a host process, and containers are running using software-defined Docker network, and that's not easy for them to work together. And when I ask why, people say like, okay, we cannot debug otherwise, and we want to be efficient. We want to debug our application normally using debugger and so on and so forth. And answer is, of course, yes, you should be efficient and debug your application with debugger, but there is no need absolutely to run this application locally, because you completely run any debug operations with application running in Docker container. So debug containerized application is different, but not hard, and absolutely doable. What changes? We will need a port to connect. For many applications, for many services, the essence of it is to open a port and serve some request, receive request, dispatch response. When we speak about web applications, it usually will be port 80. When we speak about some other applications, I don't know, using gRPC calls, port may be different, like 50,000, like we are using in our case, doesn't matter. And that's the port exposed by default, but we will need a new port, one port for the API and one port for debugger to connect. And port number changes from language to language and from debugger to debugger. We will see a couple of examples soon. And also we need the service to run with debug enabled. So service need to know what is being debugged. Otherwise it will not work. And for compilable languages like Java, you must probably going to compile it with Java debug options. And finally, we need a remote debugger session. So speaking of Java, Java can connect to any Java virtual machine if it runs locally or if it runs on another host. In our case, a remote Java virtual machine will be executed in the container, and as port is exposed, like in this example, we expose port 5005, and we simply run debugger in the mode attached to remote Java virtual machine with host localhost and port 5005. That's the port we open. And when we run application, we say to expose this port at the Docker level, otherwise port will be closed, and at the application level, so your IDE will know how to launch the application. I cannot dedicate too much time speaking on how exactly it works for this language or for that language, because again, there are a lot of languages and we have many people here using different them. So I want you to know where to go and where to search. You can run remote debugging session completely and there are no problems in that. Speaking of that, that's not only about the debug, but also with some languages like Node.js, maybe some others, you may have so-called watch. So your application has to be transpiled again and relaunched if you change some local code. And you can run watcher in the watch mode for you not to push the button every time, but simply watcher to do this job for you. It perfectly works with Docker as well, exactly the same way. So you need port exposed and you need watcher understand how to restart the application gracefully, and there is no need to rebuild the container. There is no need usually to rebuild the image. That's a very simple native manner. So the main thing you have to remember, there is no need, almost always, there is no need to run your application locally and run dependencies as Docker. You can do all the work running them all in Docker, and it gives a huge benefit. It all works in the simple Dockerized environment in the same software-defined network, and you don't need to set up any relations between the containers, pass through the ports, pass through the things, and do all the absolutely redundant job people are really doing over world in order to try to connect locally running application to Docker. Just run everything in Docker. It works perfectly. Good. So I see the team working in the chat. Yes, we have no Menti today. Menti was working very bad on morning, and I don't want to run into the situation again. We got with a freezed Menti. I promise you we will have a really great quiz, maybe using Menti, maybe not, but we will have a great Menti in the end. I mean, after this series is done. And by the way, just to introduce you some people, we have a great team working in the chat. Bettina, David, well, you know David, and Cedric answering your questions. So thank you so much. And now, finally, I heard some of you asked about continuous integration and continuous delivery. And some people say, well, continuous integration and delivery is not exactly the development part. It's kind of more to those DevOps, Ops, and I don't care. And my answer is absolute, complete no. That's exactly the essence of the development. And you shouldn't throw your code over the wall. Now you guys go and take care of that. No, that's the essence. As long as you're...
I just want to add that I'm going to stand on the same Alex soapbox right there. I couldn't agree more. Yeah, no, that's really important that you have CI/CD baked into your development process. Absolutely.
Yep. So as long as your code is not running successfully on production, your job is not done. Even after that, it's not done. But the main thing we speak today is continuous integration and continuous delivery. So when we speak about development with Docker, usually we speak about multiple people working with multiple services very often. And one of the best ways to fail, if you want to fail, is to use local build. So when I'm developing this killer video Java thing, I do all the changes, do Docker build, Docker push, and push final image into the Docker hub, and everyone starts to use that. That's it may work once, it may work twice, but in the end it leads to a failure inevitably, because local environment always affects local build. And at one point it will happen, I have something, so it will, even if I test everything, it will work on my side, but it will not work on your side because of some issues. So we want every Docker build to be executed on a remote machine, fresh, new, with no local environment affecting that. It's just a completely new virtual machine started or something, some new environment. First point. Second point, we recommend to stay lazy and use automated builds because it actually saves a lot of developer time and efforts and let you be efficient more. So auto build is absolutely cool thing to do everything. So continuous integration and continuous delivery usually done with build servers, test servers, and so on, and there are many of them, so there is a huge competition on this market. Let's say there are some open source, proprietary, self-hosted, cloud-hosted, yours, not yours. One you can make very complex things, and one you can do well, let's say simpler things, but they're easier to handle. My personal preference here is Jenkins. As it's open source, I love open source, and as with Jenkins I can launch Rocket if you ask me to launch Rocket. Jenkins is one of the most powerful tools and I love it a lot. From another point of view, it's also pretty hard to master, and that's definitely not the easiest thing to be successful with if you have no prior experience. One of the most famous build servers you may want to use, speaking of open source, for open source, although proprietary inside, is Travis CI. So if we go to GitHub things, for example, for the same killer video Java, and you see this build passing label, I bet you've seen it many times on GitHub. It means what our Travis CI he successfully built last image for the master branch of this repository, and I'm opening it right now. As an example for today of a continuous integration, I will use Travis. And if we will have a little bit of time left, I will use GitHub Actions. But what's really important here, I'm no way selling you Travis or GitHub Actions or Jenkins. They all have some pros and cons, and you have to understand that. For open source projects, I'm very fine with Travis because it works well for open source. It's free. And well, that's very fine for me, so I don't have to run my own server. With Jenkins, I have to run my own server and take care of workers and so on and so forth. So we have actually a long stack of failed builds here. I'm very curious why, but I want to show you one of the successful ones. Every line here is the job what Travis did for us due to my setup. And how do I set up that? Very easy. As we are in the killer video Java repository, we may take a look at the file .travis.yaml located in the beginning. That's the Travis configuration file. And this one is going to be pretty big one because we do some sneaky setup for this Java killer video to be built and executed, so it's a big one, but there is no magic, and I will explain you step by step. And here, following these instructions, Travis CI builds killer video Java for us, and that's open source, so you can completely go and watch how it works and use it freely for open source. So let's take a look at the configuration file first. So there are some things that was important to know. Travis tries to improve developer experience and make it easier to run. So if you say language Java, it will do Maven install for you. But if Travis makes Maven install for me, I cannot control it and I need some special configuration to make it. Instead of using Travis default configuration for Java, I simply say language generic, no language at all. Let me handle that. I know what I'm doing. And there are some minor things. We will need sudo to install some things. And we will need we will need services Docker to handle our things. And we will need sudo to handle service Docker. As far as I know, now it's not needed anymore. If you have services Docker, you don't need to define sudo, but it was a thing some years ago. And there are 5 more sections we have to take care. Script, after success, after failure, env, and notifications. So, what is the script? Script is the main thing Travis runs to define if build is successful or broken. And every step here matters except of Travis fault. You may see a lot of Travis fault here. That's just a decoration to make logs reading easier. So please just ignore everything what relates to Travis fault here. That's not the essential part. So what happened in first during the build? We are going to build this jar file. Do you remember in before I said what this killer video Java Docker file is great, except of the fact it's not just enough. It needs this file to be compiled already. So this Java jar file will be compiled during Maven install command. And what we are doing here, we are running official Maven image, specifying working directory opt killer video Java, mounting local folder, current folder as killer video Java. We are doing command maven install with some additional steps. Doesn't matter what's exactly. As soon as this command is executed successfully and only successfully, if it fails, build will be stopped. We do already build for our image and we do docker build for our local Docker file, tagging that like killer video Java local and tagging that with Travis commit. What is Travis commit? When I do a git commit, it goes to Travis, and this Travis commit environment variable is basically the git commit with this change set we are testing right now. So I will be able to access this image with this identificator and also like just a killer video Java local.
Hey, Alex, question for you real quick. For this, do we need to have Maven installed or any steps to build Maven image also or any other dependency?
Good question. So take a look. First of all, always stick to official images. Instead of developing something on your own, you will have to maintain, stay lazy, stay efficient. We are using official Maven image to build that. So this lonely word Maven, that a little bit more powerful than it may look like, because what's this Maven mean? Maven means? It means hub.docker.com/ oh my god, open. Yeah, perfect. Maven.
That was proof that we all expect everything instantaneously today.
Yeah. So that's the official Maven image, and I don't have to install it. As in this automated build, you see, we have a language generic. It means what we will here have just a plain Linux machine with nothing except of Docker installed. And I'm using official Maven image to pull it and to do Maven install. So it will be pulled from here, and mostly probably it will be something like 3.6.3 Maven. So what relates to latest? I don't see the latest text so far, but doesn't matter. It's going to be something like that. Good. So next step, that's not enough to build image. Every monkey can build an image. The question is to test that, and if it's not ready to work, don't send it to production. And that's very important. You don't want to push Docker Hub to Docker Hub or to your repository, whatever you are using, the changes you are not sure, because the moment of Docker push by you and the moment of Docker pull by production server may bring the changes, those are not intended for production. So it's very important to test everything first. And here we have this, yeah?
Alex, real quick, sorry. Follow up to that is there also any way to define our own custom Docker repository to pull from?
Yes, absolutely. So if you don't specify anything, it will use the official one, hub.docker.com. But you can also completely use your own repository on premises, or you can use Google Compute Platform, or AWS has also their own repo, and so on and so forth. So that's very easy to specify. It looks like, okay, you will not see that. The text will be too small. Okay, I will use it like that. How to use GCP Docker registry. Yeah, so I will make it bigger and you will use that. Good question, by the way. I should have covered it last workshop. Because, well, it's a pretty common case. Features. Can you just give me an example? Okay, I hope it's here. Yeah. Quick start. Yes. I just need an example of a particular line. We go. Oh my god. Okay. Yes. So here we go. That was the thing I was looking for. When you are working with official Docker image like Maven, you simply write Maven. And it will be this part, so it will be image name. In this case, that's Maven. If you want to use particular version, you set double point and say like version 3.5 or whatever you want to have. If it's image or store it on the default hub.docker.com, but it's not so kind of default one, like not just Maven, you may want to specify company. For example, project owner, project ID. When we speak of killer video, for example, if you want to use killer video image, you will pull them like that. And here we have killer video generator. So if you want to run Maven, you will simply run Maven. If you want to run killer video generator, you will run killer video / killer video generator. Now we add a company owner. And finally, if we want to use some specific registry, we just add this registry name in the beginning and add /, then owner, then /, then name, and then tag. So if you use no registry and you omit this part, it will be used as hub docker.com. That's it. Good. So any more questions? We can proceed.
No, you're good at the moment.
So now we start a thing I really don't like, because it's done wrong, and moreover, well, not wrong per se, but not optimal. And it's done not optimal by me, so there is a thing I should improve, and maybe I will show you this improvement next week. I will do my best. So we need to run tests, and we have to run integration tests. So it means that's not a unit test, those are easy to run, but we need dependencies, because integration test is about how your different systems working together. And we go here with docker compose, specifying file docker compose.ci.yaml, up -d, and which services I want to run. I want to run DataStax Enterprise, and I want to run DataStax Enterprise config for killer video. And then finally, so that's fine. There is no shame to do things like that, but this is a shame, because that means what we have no health check to check if DSC config is done already, and we just sleep for 3 minutes. And that's a bad practice, and we shouldn't be doing that. In general, that should be about to sleep as long as the DSC config is not done, or fail on timeout if job is not done within 3 minutes. What's the point? Your builds usually are executed on shared environment, and today your neighbors are quiet and you have all the server for you, and tomorrow everyone is building something, and your build, which would usually take like 4 minutes, will take 7 minutes. And those sleeps are non-reliable, and they bring a lot of delay not required, and specifically speaking, false positives, for example. When application, if it would not be ready in 180 seconds, but 182, application will be considered dead already by this time, let's say. When we run backend, and backend from this docker compose CI YAML file, we'll use already this our image. Very good. So sleep again, make it start up. And finally, there is an just check if it survived launch or not. So that's in general not the things I will show you next week at the best practices, because it's not best practices. But I want to execute command on the backend, and I'm just echoing still alive. What does that mean? It means what if we managed to execute this command, that means what container is running and operational. And a little bit of Linux magic, this double pipe set means literally OR. And if first command fails, then second command will be executed, otherwise we proceed down. So if some of you are not so much into Linux, you may be a little bit scared of this thing. Don't worry. OR means if this one succeeds, proceed down. If this one failed, do this part. And in this part, I simply write backend as down, print out logs, and exit 1. Exit 1, any exit with non-zero exit code means what build failed, and I will have red flag, and there is something to fix. And
so, Alex, here's an interesting question again from Pranali. By the way, thank you for the questions, Pranali. Instead of this script tag containing the whole set of steps one by one, can we put them in a separate file and then include that here? Is that possible?
Absolutely, that's absolutely possible. And moreover, a lot of people consider that best practice. There are different approaches, but yes, it's very often executed just a separate file. Absolutely. Yep. So short answer is yes. And finally, we do docker run killer video integration tests, which is a standalone project running API level test to our running backend. And I'm attaching it to the network killer video Java default because it's the network defined in this docker compose file by the docker compose. And that's the final step. If the last step exits with code 0, we are good, build successful, success. If it exits with code non-zero, it's something failed and build is red and we have something to check. So we built everything with the dependencies, we compile this jar file, we put this file into our already almost production image, we start integration test dependencies, those are dependencies only for test. As soon as everything is fine, we start integration tests for them. Good. And 4 last things to cover. After success, those are steps executed in case of success, and after failure, those are steps executed in case of failure. With failure, everything is very easy. I simply do docker compose and print logs from DSC config and backend containers, so I will have them in case of failure to see what happened, why it's happened, why it's broken. I don't need to have these logs as everything is fine, because, well, if tests are fine, then I don't need some well, there are a lot of tests to execute, so logs of those containers are going to be pretty long. And after success, so take a look, we built an image, we test an image. Now, what do we have to do? We have to push an image, obviously. But do we have to push it on every commit, on every change? Answer is no. It will just lead to redundant job for us, for repository, with no real benefit out of that. My approach to build images on every Git tag, you don't usually write 200 tags per day if you aren't Netflix, let's say. And also, in case of a pull requests, for some scenarios, it will be a good approach. In our case, first 2 lines in after success, they do very simple check. First thing, Travis event type. So why this job, why this build happened to be. If the type is cron, so it was scheduled, but not on commit, then I just write ignore nightly builds, terminate. I will not build image for nightly build. We just don't need that. Maybe you will need nightly build for images. That's very fine. When we do one more test, if Travis tag environment variable exists, what's the Travis tag? It will exist only if Travis works now with git tag. So we tag it this, and this is a potential release. If this environment variable does not exist, then we have no tag and we have nothing to do again. Ignore non-tagged builds, terminate. Boom, empty. And if we not quit by after these 2 lines, it means what it's not cron job and it's a Travis git, so potential release. And when here we go, I set a tag to the image we built before. Do you remember? Here was docker build -t Travis commit. So Travis commit is the identifier of the image we just built. Okay, so I do docker tag to set a new tag. I use this Travis commit as an identifier of the image, and I set this image killer video Java, and set this tag which is defined in Git. So for example, if I release something as where are my releases? If I release something as version 301 or whatever, 304, like for this killer video generator, for example. In the end, yes, very well. So in the end, I will have image tagged 304 or whatever git tag you set. Then next line is just to log in to Docker Hub to be able to push the image. And finally, I'm pushing this image to the Docker Hub with this Travis tag, so it will be available. And final line explodes a lot of brains because there is a lot of dark magic of Bash and Git and Docker, well, mostly Git and Bash. And short answer, and that's again a pretty good practice. If I release, you've seen it maybe at hub.docker.com, what then, for example, you work with MySQL, you're going to have version MySQL 5.5.4, but also you're going to have version 5.5, and you're going to just version 5. Why it's done? In some cases, you as a user of a MySQL image want to have this particular version, 5.5.4 point, like you, that's the only one you agree to work with. Whatever your reason is, I respect that. So you are going to be able to set particular Git tag. And that's what we did already. But in many use cases, you don't want to stick too much to this version. And you find if your system will just do at some point Docker pull and run next version. If you want to stick to this minor version and to use 5.5, you can set this to be 5.5 and it will be updated in some cases and you don't have to worry about that. And finally, for some of the use cases, you are completely fine with sticking just to major version. So you want to use MySQL 5.5. And that's very fine to you if it will grow higher than at some point it may be 5.8.15, for example. That's exactly the things happen right now. At first, we check if our tag is the latest tag in the repository. And then finally, we release this one as latest. So it will be, if you just want to use latest killer video Java without tags 301, 30, and so on, you may stick just to tag latest and use the tag latest. So if this tag was the latest, we will push it as a latest. If it wasn't, we will just quit. And that's after success.
So Alex, I've got a couple questions here in YouTube. The first one, I think from Jeopardy, I think you're going to address here in a moment with regard to, are the failure logs stored anywhere after the failure step?
Okay, so take a look. As I call them, so why I love so much automated builds? Because they are traceable. Because if someone did a mistake, I want to know who did the mistake and why the bad code was committed at all. And then I have automated builds. I can open every damn single line of this execution and see what was wrong, when it was wrong, and so on and so forth. So all the logs of every build is stored with build. I wouldn't say forever, but for a long time. And I don't know what happened with this build and why it's broken, but I can go and watch all the logs and what was broken with this build and find everything. And see it in any moment. Traceability. So yes, all logs are stored and available if you need them to investigate. Where exactly and how to address them depends on your build server. For Jenkins, it will be this way. For TeamCity, it will be that way. So there is no simple answer, but that's the main idea. And what was the second one?
Okay, then the other, and the second one was, will this versioning not already be handled by Maven or Maven build? Do we need a Git tag for this?
You see, you may handle things with Maven as it is, but again, let's say you have a Docker image $ABC. How do you will track it anyhow, relation to any Maven or Git tag or whatever, and how it works together? You will have to launch it, pull it, launch it, and then see what's version specified in Maven, for example. So we recommend to stick to Docker, to Git tags just for a better visibility, and when we can go and see all the tags of this image. Hopefully, if Docker Hub listens to me, Yes, and we see what we have tag latest, we have tag 30, we have tag 3, and they all are the same. So 304 is the same as 3 and 30 and latest because it was the latest one. Good. Anything else?
No, that's it for now. Thank you.
Yep.
I think, and Pranali and Jepreet, I think Jepreet, we got Jepreet the answer he was looking for, and then Pranali, okay, just said okay. So I think we're good.
Good. Very well. So there are some more things to discuss. So we discussed build job by itself. We discussed Docker file. It may be big and may be small for others of our Docker files. Those will be much smaller, but we have to proceed because we are pretty out of time and there are a couple of slides left to discuss. And final things, what happened to be, I want to discuss testing with you. Because Docker makes testing much easier if you use auto-build and CI/CD, really much easier. Before, to run an application on a testing server, it was a long job, a lot of big scripts, and so on and so forth. Now, how to run your application on staging or testing server? Git clone Docker Compose app. I love it. That's really great. Oh, sorry, one more slide before testing. But that's the thing we discussed already. Git tag should be equal to your Docker tag, or better to say Docker tag should be equal to your Git tag. That's the only way to have parity in the versions and much easier control and overview on what's going on. If by a reason it happens when this Git tag is done already, but you don't want this image to be delivered yet because you have a complex system of tests for okay, not unit but functional and end-to-end tests and so on, and you have to test it somehow, but you don't want to release the image to 0 already because, well, it's kinda what was earlier, an egg or a chicken. To test an image, you need to have it with the tag, and to when you have the image with a tag and can already somehow go to production. And you don't that as long as this image is not tested yet. How do we solve that? Easiest way for us is to use tags of a release candidate type. So if I want to test some image, if I want to see how it works, I go with the tag, for example, 2.0-RC1 for release candidate 1 and run the tests. And I can release it after some runs, if I'm fully satisfied, I can release it not only as a release candidate 1, but also as the default image 2.0, which was fully tested, and now I am fine to run it on production. Tested. Okay, tested, but how? So, you've just seen us doing some testing. And the easiest thing to set up testing in some minutes, literally minutes, is smoke testing. And that's the most underestimated kinds of testing. Very easy to implement, still discovers a lot of issues. You may say, okay, I have unit testing, I don't need smoke testing. No, you do. Because even if your code is perfect, even if your unit tests are all green and they really works, I mean, not just green unit tests. Like there were a lot of green unit tests on Titanic, you know. The point is, if the port is blocked, if the port is closed, your application will not work and you can have all the unit tests green, doesn't matter what. So, smoke testing literally is just plug it in into a power socket. If it smokes, something is wrong. Okay, but how it relates to Docker container? Very easily, run your Docker image and see if it, after a couple of seconds or whatever your timeout time to startup, if it listens on port you expect it to be listening. It's really easy, a really simple thing to implement, and it already solves a lot of issues, seriously. So that's the thing you must have always, even if you are running an absolutely crazy startup and you have no time for everything. Smoke testing is something you can do. It's a question of 15 minutes. Launch it and watch if it runs on this board. Well, then thing we use much more is functional testing, or kind of that is API testing. So what is every Docker container as it is? It's a system which usually receives some interaction, some input data from outside and dispatch some answer. And functional testing is a kind of a quality assurance process when you don't care about the internals, how it behaves internally, what language it is, and so on. But what you care, so where is the specification, what I should give? I give the input data and I receive results out of running service, and I take it and compare. If I give this service 2 and 2, I should have 4 in the end. Actually, I have 3 in the end. It looks like my famous summator who sums up the numbers works not so well and something is wrong. And you may say it looks like a unit test to you, but it isn't. Unit test you run at the very small code pieces level, and the functional testing is a full functional testing on the API. For example, in our case, for our functional testing, we need a database running behind the service. Functional testing is a bit slower than unit testing, but it's very worth it. So that's very important to have these kind of things on the API level, running the calls and comparing the results expected to actual. At this point, I will not give you any particular recommendations because there are dozens of languages and dozens of functional testing frameworks and API level frameworks, but that's definitely something you have to investigate because it's the best way of testing for Docker containers overall. And finally, we want to go to end-to-end tests. And some people may say Selenium at this point, and answer is, well, not exactly, because Selenium goes even further, so it works like a real client. It may open what your people may not push the button because this button is hidden by some overlay. I want my tests to be easier to write, so I use things like Protractor. Again, not selling Protractor, there are some more things like Cypress and so on, but my personal experience with Protractor was pretty good. And end-to-end testing is the heaviest way to run because now you need your full application operational, because it should touch at least every part of your application, but still define it as a code. So for example, Protractor tests are really easy to read. And before, for us, for all of the developers, end-to-end testing wasn't so good thing because it's again about setting up all the environment for end-to-end test. And setting up the environment was hard. And now again, git clone Docker Compose up. That's all what you need to do if you did your job right. And that was basically the last slide. Yeah, we speak of NoSQL Bench, and you can include NoSQL Bench to your tests as well, because we not only want to test the system's behavior and response, but also response time. So stress tests can completely be a part of your test strategy. What's important to notice, well, stress testing is harder because you need to have some servers guarantee dedicated for you, because if you do stress testing on a shared server, you will run all the time into the problem what today it's faster, tomorrow it's slower, not because of any of your changes, but because your neighbors are doing some job in the same data center. And as I see no more questions, we are ready to go for the week 3 assignment. And that's great. So, week 3 assignment is very heavy, uses week 2 assignment. So I have to remind what we did as a week 2. and we did a simple Docker Compose thing, application of multi-container, one pre-built, one custom, and we have to submit a new issue of the type week 2 assignment for other people to review your job and so on. And 2 people did that. Andrea and Renato, thank you so much for doing this. That's great, but I believe more people can do that. And I kindly ask you to do that finally. And you will have 1 more week to do that, but now a little bit harder. So, first thing, use the week 2 task 1 as a first step. When improve it, following these week steps, you need to use environment variables to set up. You need to use any kind of Travis build or GitHub actions. I didn't cover it today, but it's exactly the same. We need to have a little bit of test, even smoke test will be completely enough. Please use our week 2 samples for the inspiration. You can just copy paste those and expand them. That's already will be great. So you're completely good to go with forking our sample application and improving that a little bit and adding automated tests. That's very fine, and it will take you 1 hour to set it up. I mean, set up, it will take 2 minutes, and then some time to make the improvements. If you can, publish your code on GitHub and add it to our issues as I shown you right now. So we will be able to watch that and review that. I promised to review those code submissions. I will do, but those 2 were submitted too late, so I was not able to do it during the preparation for the week 3. And choose an issue. Take any of the services submitted you've seen here at the issues of the repo. There are specifications like where is the code, how it works. Watch how it's done and do maybe some of your suggestions. How would you improve that? Or maybe you will learn something from them. That's already great. And finally, if you want us to review your assignment publicly, send us an issue link to me. And we will take care of it during the best practices step, if you are able to do it in the next few days. Otherwise, we will try to cover it somewhere. Well, we will find the time. And basically, that's what it for today. Thank you so much for being with us. Amazing team. And we are very happy you like it. And we are very happy you stayed with us. Thank you, David, so much for your support. It's always exciting to work with you, and sounds great. I think we are done.
I think so. I don't see any other follow-up questions or anything. And again, I saw a lot of familiar faces and great interaction coming in. So we'll see everybody next week. Thank you.
Thank you so much. And yes, that's amazing. Thank you for the warm words. That's great. Okay, so it was Data Stacks Monday Learning with David Gilardi and Alex Volechnev, and we are always happy to make your Monday a little bit brighter. See you again 1 week later.